Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today we're going to write a C++ program to implement stack data structure using a singly linked list data structure. Yes, you heard it right. This is the part 2 of stack using linked list, and in part 1, that is in previous video tutorial of this topic, we discussed the entire working, the entire algorithm, the entire pseudocode of how you can implement a stack, that is how you can make a stack using linked list. So we are going to take singly linked list and we will make it work like a stack. That's the whole crux of part 1 and part 2, that is this topic of stack using linked list. And this is the practical side where we are going to implement this concept using C++ programming language. So if you don't know what is a stack, what is a linked list, you can check out this DSA course and check out all the different topics. We've talked about theory as well as practicals. More importantly, check the part 1 of this video, that is stack using linked list, where we've discussed the theoretical aspect, the behind the scenes working, and we've discussed those individual stack operations and the algorithms and the pseudocode. So we are simply going to convert them into C++ code. This is the practical side. So if you're just here for the programming side, then please make sure you watch this video till the end. I'm also going to explain individual stack operations by taking diagrams on the screen, so that would be a little helpful. But if you really want to understand in detail and if you don't know the details of stack using linked list, please watch the previous tutorial and then come over here. Things will be much more easier. Okay, so with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. So as you can see, I've already opened up my C++ ID and I've typed quite a lot of code actually, because I didn't want to waste a lot of time. I'm obviously going to be sharing this entire code with you guys on our official website, so you can find the link to our official website to this article where you'll get the code and some extra explanation as well. But if you're a beginner, I highly recommend you don't go there and directly copy paste it. I would highly recommend that you pause the screen and type the code yourself at least one time. Let me quickly explain to you what I've already copy pasted and already typed over here so that we do not waste a lot of time. So since this is a C++ program, on the top we have the header file, then using namespace standard, this is basic. Over here we've created the node class. So remember, we are using a singly linked list in the way of a stack. When I say in the way of a stack, it means last in first out or first in last out. That's how stack operates, right? So our stack is not going to store any integer, any character, any string value. It is going to store nodes which are there in a linked list. And that's going to be a singly linked list, but the way it is going to be stored is going to be in the way of a stack. Okay. But for that we need to create these node objects, right? And remember, our node class consists of 3 data members. One is the key. The second is the data. For simplicity purpose, we've kept their data type as integer or int. And then the third component is a pointer of the same type node. So you can see node star, it is how you declare pointers. I'm assuming you guys already know what is pointers and how you create them. And the name is next, which means that the object of node will have 3 components: key, data, and then the next pointer will point to the next node. Okay. And since it is going to be pointing to a node object only, that's why the data type is node. Okay. Simple enough. Then we have the constructor, the default constructor. That's why the syntax node and opening and closing brackets. We do not have return type in constructors. Again, I'm assuming you guys know the basic object-oriented concepts. If not, I have a separate C++ for beginners tutorials. You'll find all these topics of pointers, classes and objects and whatnot over there. But yeah, in the default constructor, we make the key and data as 0 and 0, and we make the next pointer as null. Similarly, we have a parameterized constructor inside which again we take the key as k as arguments, we take the data as d. So this is data, or it can also be represented as value. So data and value is one and the same thing. So that is passed as argument as d, and then we set the data as d and key as k. We can also make the pointer null over here also. Let's do that. So next is set to null. So whenever you create a node in the memory for the first time, the next pointer obviously is going to be null. Okay, because we have to do the linking separately by using inbuilt functions or inbuilt methods, which we will see later on. So this is the entire class node. That's about it. Let's move forward. After the node, we will have to create a class stack. So obviously the stack object will store this linking, right, of the different nodes. We've seen that in previous tutorial. And visually also I can show it to you on screen. You can see the stack object S is a stack representation inside which we will have the nodes in that proper last in first out manner, right? So in the class stack, we will have a pointer of type node and we'll name it top. So node star top means it is a pointer, its name is top, and the data type is node, which means that this top pointer will point to objects of node class. Also you can have this node star like this, or you can say node space star top, one and the same, it's one and the same. We also have a default constructor of stack class and we will make the top as null, because for the first time when we create the stack object, the top pointer inside the stack object will be null because it will not be pointing to any node initially, right? So that makes sense. Notice that everything is inside the public access modifier. This is the public access specifier or access modifier. In the class node also I've kept everything public. Typically in object-oriented programming, the data members go in the private side, that is in the private specifier, and the member functions or member methods go inside the public side. But to keep it simple, I've put everything in public side. If in case you put your data members in the private access modifier, you'll have to create getter and setter methods extra to access those data members, because once you put all the data members in the private access modifier, you cannot directly access them and you have to use your member functions only to access them. I hope you know all these basic object-oriented features and properties. But anyways, moving forward, inside this stack we still have to create all the stack operations. So our stack class is still incomplete. So all the stack operations which you can see on the screen, we have to implement isEmpty, we have to implement count, then we have push, pop, peek, and we also have to implement check if node exists. So all these 6 member functions, 6 standard stack member functions are supposed to be implemented over here, and those we will do from scratch, but everything else I have already typed. So let's first go through that. We'll come back to our stack class in a minute. So coming down in our int main function, so our main function is where the starting point is of our C++ program. In the main function, what we do, we create a stack named S1, stack object S1. We create option, we create the position, key and data. So what are these values? We do not need position variable, but we create these 3 variables and then we create a do while loop. Now what we want to do is we want to create a menu driven program where a menu will be shown, and as the printing statement says, we say cout and we ask the user what operation do you want to perform. Then we tell the user to select one option number and we say enter 0 to exit. So each option, option 1, option 2, option 3, each option is one individual stack operation, and depending upon what the number is entered by the user, let's say user enters 1, then we will perform push. And once that push is done, again this do while loop will execute itself. The reason why we are doing it over and over again is because we want our program to not exit out immediately and exit out only when 0 is entered. So when option number 0 is entered, only then our program will stop working. Till then we will keep on pushing and popping and peeking and doing different stack operations onto our same stack. That's the reason why we create a do while loop. Remember, a do while loop is a exit controlled loop which checks the condition at the end. So for the first time, all these things will run by default. And our condition over here is, if I scroll down, in the do while the condition is if option not equal to 0, then keep running this do while loop. So everything inside this do while loop will keep on executing till the user enters 0. Okay. So that's how you can create a menu driven program. Now inside this menu driven program, these are the options that will be presented to the user. Don't worry, I'm obviously going to be sharing this entire code as I mentioned. So the user will enter one option. So that's this option variable. Now depending upon what option the user enters, we will first create a node. Now there are 2 ways you can create an object. The first way is this commented out way basically. Let me just put it on top. So this is the easier way to create a node object. We say node n1 is equal to new node. So when you do this way, what happens is in the computer memory, we have two different types of memory. We have the stack memory and we have the heap memory. The stack memory is something related to static memory allocation, and then the heap is for the dynamic memory allocation. We can get into the details in some other video, but just understand that when you create a node object n1 in this way, what happens is this node is created in the stack memory as shown in the diagram, and that memory allocated is given a name of n1. Okay. However, when you create node object in this way, that is node star new node, what is this? This is a pointer methodology, right? So new node is basically a pointer of type node. But when you say equal to new node, what happens is this node is created in the heap memory, and this new node is a pointer variable in the stack memory, which is pointing to this memory location in the heap memory. So you can see in the diagram what is happening. We have new node, which is a pointer of type node, which is created in the stack memory. It is pointing to the original place where the node object is created, where the memory is allocated to this node in the heap memory, because it is a pointer. So if you're wondering why do we have these two different ways, what happens is this second way, the little complicated way using pointers to create an object, makes this new node global variable. When I say global, it means that this new node will exist throughout the program no matter what the scope is. So when you come outside this do while loop, this new node or this node object in the heap memory will still exist until you actually completely close the program or you deallocate that memory yourself. So whenever you create any object or any variable in the heap memory, it is your duty to release that memory using the delete keyword, and that's what dynamic memory allocation is all about. We can talk in detail about it later, but in our case, the reason why I'm doing this is so that this new node has global scope. The reason why we require global scope is whenever this while loop will execute over and over again, more and more node objects will be created in the heap memory and they will not be erased. So if I create a node in this easier way, every time this do while loop completes one round and again starts, the first node in the memory will be erased because it will go out of scope. Okay. And even if you are still confused, you can try it out using these two ways and you'll understand that this one will give you an error or it will give you a null pointer exception or something like that. And this methodology will work. So that's how we are going to go about it. After this, we will use the switch case depending upon what the option user has entered. If the user enters 0, we will break outside this switch case. And at the end of this do while loop, since it is 0, we will break outside this while loop also, do while loop, and then the program will stop. So that's how you exit the program. In case the user enters 1 in the option variable, then we will perform a push. In case it is 2, it is pop. In case it is 3, it is empty, and so on and so forth. Now what code is there individually inside these cases we will discuss later, but you get the idea, right? Depending upon what the option value user enters over here, we will call out the appropriate function or appropriate stack operation. Now each of these stack operation we still have to write the code, and so far I'm just giving you an overview about the code. I know I've spent a lot of time over here, but imagine if we had to actually type all this from scratch, it didn't make any sense, right? So now that you've understood the entire int main code, the only thing left out is to create these stack operations, the stack member functions, one by one. Okay. So let's start with an easy member function, which is isEmpty. Now you can see the pseudocode on the right, and there are only two basic conditions which says if top is equal to null, then this entire function will return true, else it will return false. Now visually imagine that we have a stack, okay, and when we create the stack for the first time, the top pointer inside that stack will be pointing to null. That's what our default constructor is also showing, right? So it would mean that we don't have any node inside the stack, and that's the condition that we have to check. If the top pointer is pointing to null, it would mean that we do not have any node in the stack. Simple enough. So our return type is obviously going to be bool, and we will say isEmpty as the member method name or function name. So when I say method, it is function only. Member function and member method are the same thing, but when the member function or when the function is inside a class, it is addressed as method. Okay, so do not confuse the two with two different things. It is one and the same thing. So we say bool is empty. Inside that we only have two steps basically. We say if top equal to null. In that case we say return true. In the else part we say return false. Pretty basic. This is the isEmpty function, isEmpty operation. Okay, let's move forward. Let's create the push operation. Now the push operation takes a node and pushes it onto the stack. So according to the pseudocode, we have three different conditions over here. The first use case is when the top is pointing to null, which means that if the stack is empty. So if the top is pointing to null, we simply assign the top to this new node that we are pushing. You can see we say push node n. So n is basically the new node. The second condition is if the node already exists, which means that there exists a node in the stack with the same key value. So let's assume our stack has 3 nodes already in the stack, and node n2 has a key of 2, and we want to push node n4 which also has a key of 2. So in that case we cannot allow that to happen because the key is a unique identifier of individual nodes. So you cannot have duplicate keys of multiple nodes. Okay, so that's why we have to check for that condition. And lastly, if both the conditions do not match, what would be the case? It would mean that the top is not null, which means that there are some nodes in the stack, and the node that we are pushing, let's say we have n4 which has a key of 4, that key is not matching any of the keys from the node in the stack. So in that case we simply have to push that node onto the stack. So the way we do it is we create a temporary node, we assign top to that temporary node, then we say top is equal to this new node, then we say next of this new node point to the temporary node, and lastly we say print node. So let's quickly create this push operation. We say void because it is not returning anything. We will say void push and we will say node star n. Now according to the pseudocode, obviously it is not exactly the code, right? It is just a representation of the steps. But programmatically when you are writing C++ code, we are playing with pointers. So we are going to pass a pointer pointing to that node. Remember, the new node that we create is a pointer to the actual node in the heap memory. So this new node is going to be passed. So when you do the push operation, let's see the push operation, which is case 1. Case 1 is push operation. We take the key and value of the node from the user. So key and data, that's what these two variables are at the top in the int main, key and data. Okay, we've created new node over here. We say new node of key equals to this key that is entered by the user. Then we say new node of data is the data that the user entered. Also note that this hyphen and arrow is how you can access the data members of the new node object. And if you're wondering why we are not using dot over here, it is because this new node is a pointer. It is not an object. Okay, when you create an object using this way, that is node n1 is equal to new node, then you can say n1 dot key. But since we've created a node in the heap memory using a pointer method, we have to use this hyphen and arrow to access the data members. Okay, that's the difference. So once you assign the key and data from which you took from the user to these data members of the new node, you simply push this new node onto the stack. Now as I mentioned, s1.push, and this new node is a pointer of node type. So that's why when you're creating the push function, push member function, it has to be a pointer of type node. Okay, so first condition we have to check if top is not null. That's how you check it. If top equal to null, then you simply say the top pointer will now be assigned to n. So n is a pointer of node, top is also a pointer of node, right? So if you scroll up in the stack class, you can see top is also a pointer of node. So you can directly assign this using this syntax. So the address stored in n is now also stored in top. So now our top pointer is now pointing to this new node that we are pushing. Okay, so imagine a stack which is empty as of now, that is the top is null, and if it is null, this new node that we are pushing, the address of this new node has to be stored in the top pointer. So now the top will point to this new node. Okay. Alright, so next condition is where we have to check if that node exists. So first we have to create the check if node exists, right? So let's see the check if node exists pseudocode first. So I'm gonna paste the check if node exist function over here and I'll try to explain line by line. Okay, so check if node exist is a member function which takes a node n that you're trying to push onto the stack and checks if the key of this new node matches any of the node which are already existing in the stack. So if any of the node is having the same key, then you cannot push this new node onto the stack, right? So what we do, let's assume that our stack has 3 nodes, n1, n2 and n3. n3 is on the top. The key of n3 is 3 and then we have some value. Key of n2 is 2 and key of n1 is 1. And now you want to push a new node n4 with the key of 2. Okay, that's what we are trying to push. So how does this function work? So we create a new temporary pointer temp and store the address stored in the top. So as you can see in the diagram, the top is pointing to the n3 node object. So address of n3 is stored in top. So that address is taken and stored in the temp pointer. The next thing is you create a boolean variable. We name it exist and we make it false. Okay, because this check if node exists is gonna return true or false. So if the node exists, then we will return true, otherwise it will return false. So now we use a while loop. We say while temp is not equal to null. So now right now the temp is storing the address of n3, right? So it is not null. So we go inside the while loop. We say if temp of key is equal to n of key. So right now the temp is pointing to n3. So n3 of key is 3 and n of key is this new node that we want to push. As I mentioned, this new node has a key of 2. So we are checking if the node at the top has the same key as this new node. It is not true, right? Right now we are trying to match 3 equals to 2. No. So this if will not execute. After this if, we are saying temp is equal to temp of next. Now temp is currently pointing to n3. Inside n3 we have the next pointer which is pointing to n2. You can see in the diagram. So this next inside n3 is having the address of n2. So this address of n2 is now stored in this new temp variable. Okay, and now again this while loop will execute while temp not equal to null. So obviously temp is still not equal to null because temp is pointing to n2, which means temp has some address of n2 object. Again this condition is checked. Temp of key, this time temp is pointing to n2, so n2's key is 2 and the new node n value which we are trying to pass is also having a key of 2. So now it is equal. So now we say exist equals to 2 and we break. So when we break, we completely come outside this while loop and then we say return exist, which has become true over here because there exists a node in the stack n2 which has the key of 2, which is matching this new node n4 that we are trying to pass. Okay, so I hope you are understanding. This is how you check if node exists. Now if the node n4 had some random key which is not there in any of the node of the stacks, then this while loop would have completely executed, but this if block inside this while loop will not have been executed because the temp of key will never match n of key, and hence the exist will always be false, which was set over here at the top, and then when we return exist we will return false. So this is how the check if node exist works, and we are going to use this check if exist over here inside our push operation in the second condition. So here we say else if check if node exists, and we'll pass the same n. In that case we simply have to say node already exists with this key, enter different key value. And lastly, in the else part, the third condition of push function or push operation, we simply have to add this new node n4 onto the stack. So imagine again we have a stack, we have 3 nodes already, n3, n2 and n1 in this orientation where n3 is at the top. Now we have to add n4 with the key of 4. So how do you do it? So first step, again we create a pointer temp of node type and we store the address from the top pointer. Now top pointer is pointing to n3, so n3's address is stored in top, which is then copied into the temp pointer. So temp pointer is also pointing to n3. Now of course when we want to put a new node into the stack, that becomes the new top of the stack. So now we say top is equal to this new node. So now we change the address in the top and make it point to N4. So N4 becomes the top of the stack, right? But now you can see we also have to make one more linking because it is a singly linked list, right? It is a linked list which is working like a stack. Now N4 still has to point to N3 because that link also has to be made, right? All the other nodes are linked. So this new N4 also has to link to N3. So that we will say by saying n of next equals to temp. Now remember, temp is having the address of N3. So N3's address has to be stored in N4's next pointer. Because remember, a node object has key value, that is key and data, and also a next pointer. So next pointer points to the next node. So N4's next pointer will point to N3, right? And N3's address is stored in temp. So that address is now linked, and now N4 will point to N3. And lastly, we can simply say node push successfully. Okay. So this entirely is the push operation. So I hope you've understood the entire push operation now. We've also taken the help of diagrams. Let's move forward. So now let's do the other two operations, which is pop and peek. So the pop operation basically removes the top of the stack. So we'll remove the top node from the stack. In our case, we are not exactly going to delete the top of the stack. We are going to just delink the top of the stack. Okay. When I say delink, the top now will point to the next node from the top of the stack. So imagine if we have 4 nodes in the stack, N4, N3, N2 and N1, and N4 is the top of the stack. When we do pop, what we do is we return the values of N4, and now we will make top point to N3. So N4 will be there in the memory, but it will not be linked into the stack because now the top of the stack or the top pointer will point to N3. So N3 will become the new top of the stack. So that's the whole idea over here. So let me just paste the code because again I don't want to waste time. I'll explain to you line by line and we'll take the example of a diagram. Okay, so this is the pop function, pop operation. So what we do is, let's imagine a structure of stack having 4 nodes with a given structure where N4 is the top of the stack. We create a pointer of type node and we name it temp. So remember, our pop function will return a node. So it will not return exactly a node, it will return the address of the node which is there on the top. Okay, so we are playing with pointers over here. So that's why the return type you can see is node star, which means our function is returning a pointer of type node and not a plain variable. Okay, so this is how the syntax goes when you want to return a pointer of a certain type from a function in C++ or C. Okay, alright. So we create a new pointer temp of type node and we initially make it null. We first check if the stack is empty. Obviously, if there is no nodes in the stack, it would be a stack underflow situation and we will return this temp which will have null initially. Okay, so of course you cannot pop out nodes from a stack which don't have any nodes in it. So the first condition is to check if it is empty. If it is not empty, it would mean that we have some elements or we have some nodes in the stack. So now what we do is we say temp is equal to top. So we created this temp pointer of type node. We will take the top pointer which is pointing to N4. So address of N4 is stored in the top pointer. We will store that in this temp pointer now because both of them, that is top and temp, are pointers of type node. So you can use this syntax. Now we will say top is equal to top of next. So top is pointing to N4. What is there in the next pointer of N4? It is N3's address. So this N3's address is now taken and stored in the top pointer. So now top will point N3 and then we will simply return temp. So from this function we will return a pointer which is of type node which is pointing to N4. Okay, and where will this pointer go? Let's come down in the int main. When the user clicks 2, that is pop function, let's go to case 2. This is the case 2 pop function called. We will say s1.pop and this new node that we create is obviously again a pointer of type node which is created in the memory. So this new node is having the address of a node which is created in the memory. So we will take the address of N4 which is supposed to be popped and we will store it in this new node because new node is also a pointer, right, of type node. So this new node will now start pointing to N4 from the memory. And then of course to access the key and data of this new node we can use this syntax. So we will say top of stack is new node hyphen and angular bracket key. Then we will print a comma. Then we'll say new node hyphen angular bracket data and then closing bracket. Over here you can also do delete. So let's see if we can do that. So the way you can delete is simply type delete and new node. Okay. So then this will destroy that new node from the memory. Okay. So new node is a pointer pointing to the actual object N4 in the heap memory. And remember I said that we have to delete it ourselves manually to release that memory. Okay. So you can use this delete new node. Okay. So this was the pop function. Now let's take a look at the peek function, which is pretty similar, and only the difference is that we do not delete the top of the stack. We just return it. So the code of peek is much more easier. Again, node star, which means that we're going to return a pointer of type node, which will be pointing to the top of the stack. Peek function is a standard stack function which returns the top of the stack without removing it or without, popping it out. So we'll again create a temp pointer of type node. We will initially make it null. We will check if the stack is empty. We've discussed the isEmpty function at the top. If it is empty, obviously we will return temp, which will have null. If not, we will simply return top of the stack. We don't even have to, we actually don't even have to create this extra variable, extra pointer. We can simply say return null over here and this should work. And in the else part, we will return top. So imagine we have 4 nodes in the stack, N4, N3, N2 and N1, and N4 is the top of the stack. So the top pointer is pointing to N4, which means that top pointer has the address of N4, and that address simply is returned from this peek function because top is also a type of node pointer, right? So that's why node star, and that would be option number 4. So let's see option number 4, which is this option. Over here we are checking if the stack is empty initially. If not, then we say peek function called, we say s1.peek, and whatever the pointer returns the address of N4 is stored in this new node which we create at the top. So that's why this new node pointer of type node is very helpful in all these use cases, in all these switch cases basically. So this new node will now start pointing to N4 and we can simply print out the key and data of this new node. And as I mentioned, we don't have to delete this time because in peek we only return the top of the stack without deleting it, without removing it off. Okay, so let's move forward. The next thing is count function, which basically counts the number of nodes we have in the stack. So from the pseudocode, it is pretty basic. You can see we will first create a count variable. We will assign 0. Then we will take a temporary node pointer and we will take and store the top pointer address. So imagine again the stack having 4 nodes, N4, N3, N2 and N1, and top pointer having the address of N4, which is top of the stack. We will take this address and store it in temp. Then we will run a while loop. We'll say while temp not equal to null. So till temp is not null, we will say count plus plus and temp is equal to temp of next. So every time the counts is increased and then temp will store the next node. So initially temp will have N4, then N3, then N2, then N1. And when we come at the end of the node, that is at N1, when temp will have the address of N1, the count will become 4 and then temp will become temp of next. So N1 of next, that is the pointer inside N1 is pointing to null. So that null will be stored in this temp, and then when the condition again will be checked while temp not null, it will become false because temp is becoming null. So we are running this while loop till temp is not null. So when the temp becomes null, we have to exit outside this loop and then we will simply return count, which will have count of 4. So pretty basic. The syntax is also going to be simple. This is the syntax of int count variable created, temp pointer created, which is storing the address of top. Then we loop through the temp pointer till temp is not equal to null. We keep on incrementing the count and we keep on moving forward in the stack, and then ultimately we return the count. Pretty basic. This is the count function. Okay, so we have pretty much completed our member functions. Only one last member function left is the printing of all the nodes. So void display is the function left, and it is pretty basic. Again, we say all the values in stack are, so this is the statement that we print. We take this temp node, we store the top of the stack address in this temp node. Again, we use the while loop to iterate to all the nodes, and we simply print out the key and data from every node and then say temp equals to temp of next. We can also print out the total number of nodes in the stack using this count function that we created over here. If you want, you can create it, you can comment it out if you don't want it. And that pretty much concludes all the stack operations. And let's try to see if our program runs. I'm assuming we might get some error. Let's go to execute, compile and run. Okay, we missed out on one semicolon. Don't do that silly mistake. Let's do the compile and run. Okay, again one more silly mistake. Cout endl. Okay, I'm assuming things are working fine now. Okay, our entire program is working fine, and now let's see if all the operations also work correctly. So we have been given a menu driven program. We say what operation do you want to perform, select option number and enter 0 to exit. So just displaying when I enter 0, this entire program stops and you complete and exit outside the program. Again, compile and run. This time let's do some stack operation. Now initially, obviously, as I mentioned, the stack will be empty, right? So when I say 3, that is empty, hit enter, you can see I'm getting stack is empty. And now if you see, again I'm getting the same menu driven program. What operation do you want to perform? Because I entered option number 3 and not 0. If I would have entered 0, the program would have stopped. But since I entered option number 3, the stack is empty function was called, and after that the do while loop again executed itself. So I'm getting again the same options. Now you can see I have created extra clear screen option. I forgot to show you the code. This clear screen is basically just used to clear the command prompt, and we have one standard function, inbuilt function, which says system and CLS. This should clear your screen. So if I hit 7 and if I hit enter, you can see the extra screen got cleared out. Alright, so isEmpty we just checked. Let's see the count. The count obviously should be 0, right? So when I hit 5 and when I hit enter, you can see count function called number of nodes in stack is 0, because we still have to push some nodes into the stack. So that's why initially it is 0. Again, I'm going to clear the screen. Let's push one node. So when I hit 1, it is for push. Now it is asking for key and value of node. So I'm going to hit 1 and 10. So 1 is going to be the key, 10 is going to be the value or data. And when I hit enter, that node is pushed onto the stack. But we did not get a message saying node pushed successfully. And that is because initially the top was null. So when the top was null, we simply said top equals to this new node, but we did not print node pushed successfully. So let's copy this and hit or paste it over here, and again we'll say execute, compile and run. Let's push one node. I'll say 1 and 10. So initially the top is going to be null, and then it will be pointed to this new node, and now you can see node pushed successfully. Okay, so now let's see if isEmpty works. Let me just first clear the screen. isEmpty is option number 3. So you can see stack is not empty now. Let's take the count. Option number 5 is for count. You can see count function called, and number of nodes in the stack is 1 because we pushed one node into the stack. Let's clear the screen now, and let's see display. Display is option number 6. We just pushed one node with key as 1 and data is 10. So you want to see that. So when I hit option number 6 for display, there you go, you can see all values in the stack are 1, 10, and then the singly linked list icon of next, which is basically pointing to nothing because we only have one element or one node into the stack. Let's push one more value. I'll hit enter as 1 for push. Again, it is asking for key and value. Let's try to duplicate the key. Let's say key is 1 and value as 20. We should not be able to push this because the key cannot be same. We already have one node with key as 1. So when I hit enter, you can see I'm getting an error message. Node already exists with this key. Enter different key value. And then again this menu driven program is shown. So I'm going to hit 7 and clear the screen. Let's push one more value with key as 2 and data as 20. And now the node is pushed successfully. Now let's take a look at the count. count has become 2. And let me clear the screen and let's see display, which is option 6. And there you go, you can see all values in the stack are, the top of the stack this time is 2 and 20. Then we have the next link, which is 1 and 10. So the reason why I printed it one below other is to represent it like a stack, and 1 and 10 is pointing to nothing. Okay, let's push one more. We will say 3 and 30. Clear screen, again display, which is option 6. There you go, now 330 is top of the stack, 220 is second, and 1 and 10 is third. So N3, N2 and N1 you can consider 3 nodes in the stack. Now let's take a look at pop. Pop means the top of the stack should be popped off, which means 3 and 30 we should get. Let's do option number 2. Hit enter and pop function called popped value, that is top of the stack, is 3,30. Okay, so 3,30 should be removed from the stack, right? Let's clear the screen and now let's take a count. There you go, you can see number of nodes in the stack is 2 and not 3. So clearly N3 is removed, right? But to make sure of it, let's display option number 6. Hit enter and there you go, you can see now 2 and 20 is top of the stack and 3 and 30 is removed from the stack. So pop is working perfectly fine. Let's clear screen and let's use peek, which is option 4. This should only return the top of the stack and not remove it. When I hit enter, peek function called top of the stack is 220. Is it still there in the stack? Let's see, option number 6. There you go, 2 and 20 is still there into the stack. Okay, so this is all the stack operations where we implemented a stack using linked list and we stored different nodes in the stack orientation, that is last in first out orientation, and implemented all the stack operations onto this linked list. Okay, so this was the entire program. I hope you got the entire working. I've already explained the working in detail in previous tutorial as well, but I hope now you also understand the program and the practical side of it and you can implement such kind of programs on yourself. I'm obviously, as I mentioned, going to be sharing this entire code along with the theory onto our official website. So make sure you check out the link in the video description to get this entire code. This is working and perfectly fine. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends. If you're using any other programming language, the algorithm, the pseudocode is pretty much going to be the same. Just the syntax will change. And this is where I'm going to wrap up and conclude this video. So thanks for watching. See you in the next one. Peace.